Hey everyone, my name is Andile and welcome to Probability. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. Now, if you're currently sitting below 50%, I highly recommend that you start with Solve for X, not because I want to discourage you, but because this section is foundational. And if you understand Solve for X, trust me, everything is going to be easier. And again, in this video, if we come across anything that is related to Solve for X, I'm not going to go deep into it as I'm going to assume the fact that you already know the knowledge. Hope that makes sense why it's very important to basically start with Solve for X. And again, Solve for X is a foundation of every topic because you're going to come across it in every topic that we're going to do from now on, right? Now the video breakdown. The video is going to be divided into 4 sections, which is section 1, basics of probability, section 2, Venn diagrams in events, section 3, probability representation, then section 4, counting principles. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I say, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
So welcome to probability. So the first thing that we're going to do is we're going to do grade 10 revision, right? Then with grade 10 revision, we're going to first talk about the union. What is a union? Union is an addition, right? So this is addition, right? It's adding two events. The two events here is going to be A. A is an event, right? Then B is also an event, right? So when they want the union, we're basically talking about the addition and showing it in a Venn diagram. It's going to be shading both A and B, which is going to be represented as A union B, like this, right? Or it can be represented as A or B, which means the fact that we are finding the addition of two events, right? So that's what a union is. Now we're going to move to intersection, right? Intersection is when two events, which is we see the fact that we have event A and event B, right? It's when two events intersect. Do you see the fact that the shaded part, the yellow part, is going to represent the intersection? And how do we represent it? We represent it as A with and like this, like the symbol B. Or we can say A and B, which means the same thing, which is we mean what? We're finding the intersection, right? So now what we're going to talk about mutually exclusive. What do we mean when they say the fact that two events are mutually exclusive? Is that when you have two events, which is we have event A and event B, and they do not have an intersect. Do you see the fact that both A and B, there's no intersect, right? This is going to be considered as what? As mutually exclusive, right? So when the minute you have two events and there's no intersect, as you can see, two events that are separated, that are acting on their own, then we're going to say the fact that the two events are mutually exclusive. Now we're going to talk about what do we mean when we say the fact that an event is complementary, right? So here we have two events. You see the fact that we have event A and event B. When we say the fact that not A, what do we mean, right? We mean everything. So not A means the fact that it's everything besides A, right? So in our diagram here, what you call this, event A is going to be the one in white, right? So event A, right? So A is going to be the one in white, right? That is going to be the one in white, right? And not A is going to be the one in yellow, because of its everything that is not white. I hope that makes sense, right? So not A, which we're going to represent like this, right? Or you could say, or you could write it like not A, the way I wrote it in the bottom is going to be the one in yellow, right? And the reason why for the not A, the reason why we're not including the intersect is because of the intersection contains A, and we want everything that is not part of A. So it's going to be everything excluding the intersection, right? And everything around it. And that's going to represent what? Not A, right? So same thing, same concept. Not B, right, is going to be everything that's yellow. So we see the fact that not B is going to be the yellow part, right? So here, not A is going to be the yellow part, right? Then B, we see the fact that it's the white portion. So we see the fact that B is going to be the white portion, right? So this is just to see, this is for you guys to see visually what does it mean when we're talking about complementary events. And right, when we say not A and not B, how to see it visually on a Venn diagram, right? So now we're going to talk about probability identity, right? So with probability identity, this is the following identity that you need to know that you're going to use with your calculation, right? So the first one, this addition one, right? It's when there is an intersection, right? So the first one, it's used when there is an intersection, right? And so this is for when there is an intersection. And it says the probability of A or B is equals to the probability of A plus the probability of B minus the probability A or B, right? So here we're looking for the probability of what? Of when we add up. Remember the fact that O is what? It's addition. That is why it's called the additional rule, right? So this is when we add up two events. This is how you would do it. If, very important, if there is what? If there is an intersection, right? So just to see it visually, let me just do this probability A plus the probability of B in terms of the Venn diagram, right? So we see the fact that we're going to have two events, right? You're going to have A because of there's an intersection, and we're going to have B, right? So this is going to be A and B, right? So what we say is that the probability of A plus the probability of B is equals to the following, right? It's going to be equals to, let's represent this one, right? It's going to be just the probability of A, right? So this one, let me just I'll write it here in the bottom. So this will be representing the probability of just A, right? So this is going to be the probability of A, just to show you guys in the Venn diagram. So this one represents the probability of A, right? Then plus the probability of B. So it's going to be two Venn diagrams that are what? That are added together, and this is A and this is B, right? So the probability of B is going to be represented everything in B, so it's going to be like this now. So it's going to be plus the probability of B, right? Then that is going to be equals to what? Plus minus what? So it's going to be minus, it says it's the probability of A plus the probability of B minus the probability of A, right? And B, so minus the probability of A and B, meaning minus the intersection. And I'm going to tell you why we minus the intersection. So minus this intersection, right? The reason why we minus the intersection, do you see the fact that when we added up the probability, so this is actually the probability of A and, let me just do this, and B, right? So this is adding, right? And this is subtracting. The reason why we subtract this probability of what? Of A and B, right? Is that, do you see the fact that in probability of A, we included the intersection, right? And also when we found the probability of B, we added the intersection. Do you see the fact that the intersection is added twice here, right? So now we need to subtract the extra one. That is why we subtract the intersection. And this thing is going to create what? It's going to create, this thing is going to be basically equals to the probability of A plus the probability of B. So it's going to be equals to A, B, right? So this is going to be equals to what? To A or B, right? Which is, or it's the same thing as this one, right? So this is basically going to be equals to that. So do you see the fact that it makes sense if you look at the Venn diagrams, right? Do you see the fact that this one represents this one represents this one, then the intersection. So that's how you would see it visually, right? So that's how you would see the additional rule So now let's do the second one. So this is when there is an intersection, right? So now the second one says additional rule when you have two, the additional rule when the events are what are mutually exclusive, right? So when they're mutually exclusive, remember there is no intersection. So it's going to be the same as the probability of A, which is going to be, this is A. So this is going to be the probability of A, right? Plus it's going to be just the probability of what? So this is going to look like this. Let me just do this. It's going to be the probability of A, right? So you're going to have two events. So it's going to be A and B. But remember the fact that they are separated. So this will be the probability of A. Then this is going to be the probability of B. I'm going to shade it. Don't worry. Right? So it says the fact that you just add the two events together, right? So this is the same as the probability of A. And this is the same as probability of B, right? So this is going to be the probability of B, right? Plus the probability of B. And we say the fact that this is equals to what? To the probability of A and B. So this is going to be A and B. So this is basically equals to the probability of A or B, right? Or B, right? Which is what? Which is both of them shaded in together. Do you see? So this represents the second one. So I'm just showing you in terms of Venn diagram. I hope that made sense, right? Then the second, what you call this identity or rule, it says the probability of not A is equals to 1 minus the probability of A. So it's everything that is outside. One thing that we discuss here. Do you see the fact that it's A, right, minus the entire thing, which is 1. Because of the reason why it's 1 here is that since we're dealing with probability always adds up to 1. So let me just write that comment, is that because of probability, right? Probability adds up to 1. And that's always. So if we're dealing with probability, it always adds up to 1, right? Then the next one is the product rule. It says the probability of A and the probability of B, right? And is equals to both of the probability, adding them together. This we're going to look at it later on. It actually tests what? It tests independence, right? So this tests independence, right? So that is what you call this probability identity, right? Just so that you can see it visually. Everything is going to make sense the minute we do questions, right? But before we do questions, there's actually extra tools, right? To basically help you guys when answering questions, right? So this is going to be very important. This table is going to be very important, right? And this identity are going to be very important. So let's look at the table, right? So if in the question they say the fact that they use the word all, right? And you're going to see when we're doing questions, it's that they mean the fact that here they're looking for the intersection, right? So here it means the fact that they're looking for the intersection, right? The minute they say none, what does it mean when they say none? It's nothing, right? So it's nothing that is inside the event. So it's everything that is outside. That's what none means, right? Then when they say to you at least, they mean the union, right? Meaning they mean addition. So this means the union. Or addition, as you can see here, right? Then when they say both A and B, right, they mean what? They mean the intersection again. And again, you can see with the word and to know the fact that they're talking about intersection. So here they're talking about intersection, right? And the last one, when they say or remember, it means what? It means what you call this union. So it means union, right? So that's the terminology or the extra tool that I just put there so that you can see it. And as you can see here in the Venn diagram, it represents everything that we just talked about, right? All means what? Intersection, which is you can see the fact that they shaded in the purple part. None means the fact that none of the events, which makes sense. So it's going to be everything that's outside it, right? What you call this at least one, right? It's going to mean what? It's going to mean the fact that it's either one. Let me just explain the at least one so you can see it, like what you call this, you can understand what they mean, right? At least one means the fact that it's either that one event. If it's like 3 events, if we have 3 events, right? At least one means the fact that it's either it can be 1 event, it can be 2 events, or it can be 3 events. That is why we add up the entire thing, because of is that it's at least one. So it can be 1 event, it can be 2 events, or it can be 3 events if we're dealing with 3 events, right? Then the intersection, we see the fact that both A and B, we see the fact that the purple part, it talks about the intersection. And the union, you already know the fact that it's both of them, or means both of them, right? So that is just going to be what? The terminology and the extra tools under what? Under probability identity, right? So now let's do an example to sum up everything that I've been saying, because we were just talking about the terminology and things that you need to understand, right? So this example has the probability identity. As you can see, the fact that I've put the probability identity on the side, and it also has what it has. It deals with the Venn diagram, right? So this will be the introduction to how to basically deal with Venn diagrams, right? So it says what? It says, so let me take my highlighter. It says in a survey of 70 people, so they tell you the fact that the total amount of people in the survey, meaning this is going to be what? This is going to be your total sample, right? So your total sample is going to be represented as NS, right? So your total sample here, the number of people in this study or in this survey, we know the fact that it's going to be 70, right? So S represents the actual total sample of people, right? It says, well, questioned about which product they used, right? So they tell us the fact that there is 70 people that were questioned what product they use, right? Then they say the fact that we need to use A or B for both, right? So we need to use A or B or both, right? The reports, what you call this? So the people that they use. So the report of the survey is about, they say the fact that the report of the survey shows that about 25 people, so let's highlight that part, right? So it tells us the fact that 25 people uses product A. So what do we know from here? We know the fact that 25 people, so we see the fact that, and I'm just going to write it here, right? I see the fact that 25 people use product A. So N represents the number of people, then product A, right? 25 people use product A, right? And it tells us what? It tells us that 35 people use product B, right? So we know the fact that N, B uses what? It uses what? It tells us the fact that 35 people uses product B. So it's going to be 35 people, right? So we see the fact that we have the following: 35 people use product B. Then it tells us the fact that 15 people, right, use neither. So 15 people don't use product A and product B, meaning it's going to be the people that are outside the Venn diagram, right? Then it says what? Use the Venn diagram. Use the Venn diagram to work out how many people. So let's do that. So it's going to be this, right? So it's going to be 2 circles, right? So we see the fact that what's going to happen, we're going to have 2 circles. So we know the fact that, and here they said both, right? Meaning the fact that there's going to be an intersection. There's a point where they intersect. Because they say the fact that what was the question used? They said they use A or B or both. Both meaning the fact that this Venn diagram has an intersection, right? So our Venn diagram is going to actually have an intersection. So first, let's sketch the intersection, right? It's going to be 2 circles. So let me just do this. So it's going to be 2 circles. So it's going to be 2 circles. So it's going to be event A. Then it's going to be event B. Right? Then we know the fact that, so it's going to be, let me just close it up. So let's close it up like this, right? Then we know the fact that is the number of total people comes here at the top. So it's going to be N is sample, which is going to be 70, right? Then we see the fact that we're going to have event A, then we're going to have event B, right? Then they didn't, from our information, do you see the fact that they didn't give us the intersection? So the intersection, since the number wasn't given, right? That's going to be represented by what? By X, right? Then what do they tell us? They tell us the fact that 15 people do not use A or B, so the 15 is going to be here, right? So that's what you need to know, right? Then after that, what do we know? We know the following is that they gave us the entire event A, right? So event A is going to be everything here. Do you see the fact that this is going to be the entire A, right? So this is going to be the event A, right? So meaning this 25 is going to be this A, including the intersection. Since we have the intersection as X, that is why we're going to say this is going to be 25 minus X, right? Because of we need to subtract the intersection to get just A alone. I hope that makes sense. And then to find event B, right, it's going to be the following. It's going to be this whole thing, right, including the intersection, right? So it's going to be what? It's going to be 35, right? So this is going to be what? It's going to be equals to 35 minus X, right? Because of we need to take out the intersection, right? So first, before we do the calculations and answer the question, we need to solve for X, right? So what do we know about the relationship, right? Is that if we add up all the, all the numbers here, this is going to be equals to the sample. So if we add up event A plus the event B, right, then plus the intersection, plus this 15, the people that are not using product A and B, we need to get this total, right? So that's what we know, right? It's one of the rules that we know, right? So we know the fact that 25, right? So we know the fact that 25 minus X, right, plus X plus what, 35 minus X, right, is a plus 15, right? Don't forget this 15 is actually equals to the sample. So what I mean is that everything that is in the square, right, when you add it up together, it needs to give you the total of the sample. Remember, everything that's inside the square, right, when you add it up, it needs to give you your total of the what, of the sample, right? So now it's going to be what? Add numbers together. So when you say 25 plus 35 plus 15, you're going to get what? You're going to get the fact that you're going to have 75, right? Then when you say negative X, right, those one are going to cancel out. Then when you say X, so when you say negative X plus negative X, you're going to get basically negative X, right? And that's going to give us what? That's going to give us 70, right? Take the 70 to the other side. It's going to be X, negative X is equals to negative 5. Therefore, X is basically equals to positive 5, right? So we know the fact that X is going to be equals to positive 5. So here, and I'm just going to write it with another color. So here, I'm going to rewrite everything. So we know the fact that X here, right, is equals to what? To positive 5. So I'm just going to write it with another color. So we know the fact that this is going to be 5. Then when you say 25 minus 5, this A alone is going to be 20. When you say 35 minus what? When you say 35 minus 5, this is going to be what? It's going to give you 30. So this is how your Venn diagram is going to look with the red numbers, right? So now with that said, let's answer our question, right? So now going to number 1, right? It says what? It says, use the Venn diagram to work out how many people use product A only, right? So how many people use product A only, right? So only, the word only means the fact that you cannot at the intersection. So when they say product A only, remember the fact that the intersection is not included. So only means no intersection, right? Because remember the fact that intersection has what? Has both B, right? So only means the fact that there is no intersection. So here, right, the people that use what? Product A only is going to be 20 people, right? So it's going to be the 20 because of, do you see the fact that it minuses the 5? So it can't be the 25. It's going to be just 20. So it's going to be 20 people, right? Then number 2, right, it says what? It says product B only, right? Meaning there is no intersection, right? Meaning it's going to be what? The answer there is going to be 30 people. 30 people. right? Not 30 people's. Then it says uses both, very important, both product A and B, meaning we're looking for the intersection. So number 3 is going to be what? It's going to be 5 people, right? Then number 4, it says what? Uses at least one, right? At least one. Remember the fact that from our notes, we said the fact that at least one means what? Is addition, right? So at least one is going to be what? So it's going to be number 4. At least one means the fact that is A or B, right? What do we know that A or B is equals to what? We know the fact that A or B is equals to what? Is equals to A plus B minus what? Minus A and B, right? That's what we know. So let's do that. So remember, at least one means what? From here, it means it's addition. So it's going to be adding up this 3, right? So it's going to be what? It's going to be equals to what? It's going to be equals to 25, right? A, the entire A, remember, is 25, right? Then it's going to be plus what? It's going to be, or you can just make it simple. It's just this without using even the identity, right? A or B represents the following, right? It's going to be, and I'm just going to take it off because I don't want to shade in. It's going to be adding 1, 2, 3. That's A or B, right? That's at least one, sorry. That's at least one, right? Which is adding what? This thing. Do you see the fact that it means you shading in the entire thing? So you're just adding up 20 plus 5 plus 30. And even if you use the identity, you're still going to arrive in the same answer. So this is going to give you what? This is going to give you 55 people. So we're done with that. It says, number 5, do not use product A. So, meaning we're looking for what? So for number 5, we're looking for not A. Do you see that? We're looking for not A. What did we say? The fact that it's not A, it's going to be the sample. So it's going to be the total sample. So it's going to be equals to 70 minus what? It's going to be minus A. So it's going to be minus A, which is A. Remember the fact that A includes the intersection. So it's going to be minus 25, right? So here, not A, let me just write it in formula form first so I don't confuse you guys. So not A in formula form is going to be what? Since here we're dealing with the sample, we're not dealing with the probability, right? It's the same as the total sample, which is in S minus what? Minus A, right? Which is we have the total sample in A. So this is going to be equals to what? It's going to be equals to 70 minus 25, which is we're going to get as being what? Which is we're going to get as being 45, right? Then number 6, what you call this? Do not use product B. It's going to be what? It's going to be not B, which is going to be what? Which is going to be is, right? The total minus B, which is going to give us what? Which is going to give us the following. It's going to be, it's going to be 70 minus what? Minus 35, which is going to give us what? Which is going to give us 35. And let me just add one more, right? Let's say number 7. It says what? It says do not use A or B, right? Do not use A or B is actually equals to 15. So number 7 there is going to be what? It's going to be everything besides this part. So it's going to be everything that's outside. It's going to be what? Not. So I'm just going to say not A or B, right? Remember, we can't take everything that's inside. A or B is this whole thing. So A or B is going to be the shaded part. So A or B, which represents the green part, right? That's A or B, right? So we want something that's not part of that, which is going to be this 15. So not A or B is going to be equals to what? Let's just do it the way we did it. It's going to be in, right? Then it's going to be A, just to show you the fact that it works. A or B, right? And that's going to be what? It's going to be not A or B, it's going to be the total sample. So it's going to be S, right? Remember, it's the total sample, which is going to be S minus N. Then there's going to be A or B, right? Which is going to be what? Which is going to be 70. Remember the fact that we found A or B. We found that A and B is equals to 55. So it's going to be minus 55. So take your calculator. If you say 55 minus 70 is going to give you what? It's going to give you 15. Do you see the fact that it rounds up to what? To exactly this 15 here. So that's how you would answer these questions. So now what we're going to do, we're going to do grade 11 revision, right? So here we're going to talk about independent, dependent and independent, right? So it says definition, right? Independent events, two events A and B are independent, very important, if and only if you find what? The intersection, it's going to be equal to the probability of A multiplied by the probability of B, right? So with this said, this states when this is what? This is independent. So if these two are equal to each other, then we know the fact that the two events are independent, right? Right? So now let's talk about when they're not independent. So I'm going to talk about this one, right? What does it mean when it's not independent? And I'm just going to highlight it, right? So what does it mean when it's not independent? It means the following. It means the fact that this does not hold. So probability of A and B, right? It's not going to be equals to what? It's not going to be equals to the probability of A multiplied by the probability of B. So that's what it means, right? Also, if we are given that two events are independent, that means we have an intersection. Very important, right? So this part is very important. If we are given, let me just highlight this part. If we are given the fact that the two events are independent, right? That means the what? We actually can find what? We can find the intersection. And because of this relationship, do you see that? Is that if I add two probabilities together of A and B, I can actually find the intersection, because remember that this part is the what? Is the intersection. Right? I hope that makes sense. So with that said, let's just put everything that we just said in action, right? So the question says what? It says use a Venn diagram, which is they gave us, right? To determine whether event X and Y are mutually exclusive, right? So from just looking at the diagram, we know the fact that A, they are not mutually exclusive. And reason why is because of there's an intersection, right? So to answer number A is that what? Not mutually exclusive. And it just shows because of there's an intersection. You can see it visually, right? So not mutually exclusive. Right? So B, it says what? It says test whether it's independent or what you call this independent or dependent, right? So here we need to test whether the two events are what? Are independent or not, right? So very important. It does not mean if there's an intersection. Very important. I'm going to just repeat it. It does not mean if there's an intersection, then by default the events are what? Are independent. You still need to test. Intersection does not. So let me just write it down, right? Intersection, right? Does not mean, right? Does not mean independent. It does not mean that, right? But, so intersection does not mean independent, but, right? If the events are independent, we can find the intersection. I know the fact that it's like quite confusing, right? So if the events are independent, we can find intersection. But intersection does not mean the fact that they are what? They are independent. If you have an intersection, you still need to test whether the two events are what? Are what you call as are independent. Remember the fact that to test, we need to test the fact that the probability of A, right? The probability of X in our case, So it's going to be the probability of X. Let me just do that. Let me just even change the color. So it's going to be the probability of X and Y is basically equals to what we're testing is equals to X multiplied by probability of Y. So now I'm going to show you on how to find probability because I haven't shown you, right? So to find the probability, it's going to be what? It's always going to be the number. So let's do the left-hand side. So it's going to be the, what you call this? Because this is left-hand side and this is right-hand side, right? So the probability is going to be what? The intersection is this tree, right? So the probability of A, X, and B, you already know that intersection is 3, right? So it's going to be equals to what? It's going to be equals to 3, which is that's the intersection, divided by what? By the total. What is the total number of sample here? So we need to find the total number of sample. It's adding these numbers all in. It's adding up all the numbers in the triangle, in the rectangle, right? So it's going to be 11 plus 3 plus 7 plus 14, right? That's going to be the total sample. So this is going to be 35, right? So the probability is always going to be what you're looking for, which is in our case is the, so it's going to be the intersection divided by what? By the total, which is going to be 35, right? So when you simplify that, you get the fact that your value is going to be what? It's going to be 0.09, right? So what is going to be the probability of X is going to be the following. It's going to be 11, right? Plus the intersection, so it's going to be plus 3. And that's going to be divided by what? By 35. Remember the fact that the 3 also includes X, right? So this is going to give you what? This is going to give you 0.4, right? Then the probability of Y is going to be equals to what? It's going to be equals to, what you call it's going to be 7 plus the intersection, which is 3, which is going to be divided by 35 by the total, which is 35. So this is going to be 0.29, right? So now we need to multiply it. So remember the fact that this one was the what? The left-hand side. And here we're looking for the right-hand side, right? So the right-hand side, remembers what? Is equals to what? It's equals to the probability of X, right? Multiplied by the probability of Y, right? So let's multiply them together. So when you multiply them together, we have the following. We're going to have that in 0.4 multiplied by what? By 0.29, right? So punch that into the calculator. You're going to get the fact that it's going to be 0.116. Do you see the fact that this answer here, I'm just going to highlight, do you see the fact that this and this are not the same, right? So since they are not the same, so we see the fact that probability of X, right, and Y is not equals to the probability of what? Of X multiplied by the probability of Y. So since they're not equals to each other, so therefore we can conclude the fact that it's what? It's dependent. The events are dependent. So that's how you would answer this question. So now we're going to move to 3 events, right? Venn diagrams, meaning we're going to have Venn diagram that's going to look like this. Now, instead of 2, we're going to add 1 more. So it's going to be 3 events, right? So with 3 events, we need to understand what is the identity for the addition. So this is going to be what? The addition, right? So this is for addition or O, right? It's going to be equals to the probability of A. So this is A, B, and C. So it's basically equals to the probability of A plus the probability of B plus the probability of C minus the probability of A minus the probability of C minus the probability of A and C. So it's minus the probability of the intersections of the individual. Then we add back the intersection. Just remember this identity because it's going to be very important, right? So this is going to be for what? When you're dealing with 3 events, not 2, right? So now with that said, let's do a question that's regarding what? That's regarding drawing a Venn diagram for 3 events, right? So it says there are 20 there are 200 boys, imagine 20. There are 200 boys in grade 11, right? In high school, they participate in sports that can be broken down into the following. So the sport is broken up into the following. So we see the fact that looking at the sports, we need to identify the type of sports that are there, right? So we see the fact that they say that 107 play rugby. So we're going to represent rugby by R. Then they tell us the fact that 90 play soccer. So it's going to be S. Then they tell us the fact that 63 plays cricket, right? Then it says 35 plays rugby and cricket. You see the fact that that's going to be R. And so it's going to be and rugby and soccer, sorry. Then they tell us what here? They tell us the fact that 23 plays rugby and cricket. So it's going to be R and what? And what? R and. So we see the fact that's going to be R and C. Then it tells us the fact that 15 play rugby, soccer and cricket. So this is what? This is R, this is S, and this is C, right? So they play all three. Then they tell us the fact that 190 students play rugby. They play rugby, cricket, or what you call this? Rugby, soccer, and cricket. That means the fact that it's O. Do you see the O? So it means the fact that they mean this. So it's going to be, let me just do this. So this is basically representing R, O, S, O, C, right? So that represents that. Then now is the questions, right? Before we answer the questions, we need to do what? We need to fill in the Venn diagrams, right? So if you have 3 events, you're going to have 3 circles. So you're going to have the following. So it's going to be R. You can name it the way. So this is going to be 3 events. And we know the fact that there's intersections because of that intersection that are showing, right? So now we know the fact that this is going to be what? This is going to be R, right? This is going to be S. Then this is going to be C, right? Put it in the square. Right? Put it in the square. So we can answer the questions. We know the fact that the total sample is 200 because do you see the fact that when we started the question, they say the fact that there are 200 boys. So we know the fact that N S here is basically equals to 200, right? So with that said, let's fill in the information that we have, right? So always if you're dealing with Venn diagrams of 3 events, you always start in the middle, then you go outside. Never start with here because it's going to affect this intersection affects your what? Your actual whole numbers, right? So you always start in the middle, then you go out, right? So now we're going to start from the main intersection, right? The main intersection is this one where it's R intersecting S intersecting a what? Intersecting C. So 15 is going to come here. Let me just write in another color so you can see it. 15 comes here, right? So this is going to be 15. So I'll hope this, right? So this is going to be 15, right? So this is going to represent 15. So we know the fact that the main intersection is 15. You always start from the main intersection going outside. Very important. If the main intersection is not given, you're going to name that main intersection X. Then you go outside because of this one, that where we started affects everything. I hope that makes sense, right? Then we're going to go to the respective intersection, right? We see the fact that the intersection of R and S, right, is what? It's 30. So we see the fact that R, right, R is here. And we see the fact that S, right? So we see the fact that S is here, right? We see that their intersection is 35, right? But this 35, it's very crucial because of we need to take out what? From this 35, we need to take out 15. Because remember the fact that, let me just do this, that 35, right? 35, this is the intersection. Do you see that? Right? The 35 that they gave you is this whole thing. But what we need to fill in right now, it's only this portion, right? Do you see the fact that it's this portion? So if it's that portion, we can't say the fact that that's 35, right? Because of it has, that 35 is the whole yellow one. I hope that makes sense, right? So the small portion is going to be 35 minus 15, right? So it's going to be 35 minus 15. So when you say 35 minus 15, here you're going to get what? You're going to get 20. So this portion is going to be 20. So same applies with this one here, right? This one, the intersection between R and S, right? It's what we given as being 23. So we're going to say 23 minus what? Minus 15. So that's going to be what? That's going to give us what? 23 minus 15. It's going to give us 8. So this is going to be 8. Right? So now we're going to move to this side, right? Do you see the fact that we have already filled this portion? Now we're going to fill this portion. Let me just highlight that portion, right? Just going to do it with, let me just take my highlighter. And I think I'll just go with orange, right? I'm talking about this portion here, right? So we're going to talk about this portion. If you look at the information that we're given, we're not given the intersection between soccer and what? And cricket. We're not given the intersection between the two. So meaning the fact that that portion is X, right? But remember the fact that the whole thing is X, but this portion here, the small portion here, right, that we need to take account to, this portion here is the one that we were not given, right? We were given the main intersection, which is 15. So this portion here that I just highlighted in blue is going to be what? It's going to be the following. Let me just take my pen. Since we know the fact that, let me just do this, right? Since we know the fact that the intersection, let me just write it here, right? We were not given that the intersection between S and C, right? Soccer and cricket, right? So I'm going to name this intersection X, right? So this whole thing, the orange part is going to be X. But remember the fact that that orange part contains what? This X has 15 in it, right? So just the blue part of it is going to be what? It's going to be us taking out this 15 the way we did here and the way we did here. So this portion here, this blue, it's basically going to be X minus what? Minus 15. So that's how you would get that section, right? So let me just write it properly. All right. So that portion, as I said, the fact that it's going to be what? It's going to be X minus 15. So this part is going to be X minus 15. Because remember the fact that the whole thing is X, but this point here, this is 15. Why did I say 5? Right? But this small portion here, right, that does not have this portion here, it's going to be minus 15 because the whole thing is X. Now we're taking out 15 the way we did here and the way we did there, right? So that's what we have. So now with that said, right, we're going to move outside now. We're going to move outside and look at just R and look at S and look at C, right? So now when we're looking at R, right, what do we see? We know the fact that the entire of R, right, they tell us the fact that 107, what you call this play rugby. So the whole R, right, it's going to be what? It's going to be 107. But in that whole R, it contains this 20, this 15, and this 8, right? So to find this portion, and I'm just going to highlight it, right? To find this portion, let's just take yellow. And yellow is already taken. Let me just do orange again. To find this portion here, right? The one that does not have the intersection, right? What do we need to do? We need to subtract 20, 15, and 8 into from Y? From 107. So that's what we're going to do, right? So if you say, or what you call this, 107, right? Take out 20, right? Take out 15, because of if we leave it, right, instead we're going to duplicate it, and we don't want to duplicate anything. Then we minus 8, we're going to be left with 64. So that portion here is going to be what? It's going to be 64. So now moving on to what? Moving on to finding S, right? So now to finding S, remember the fact that we already said what? We already said that this whole thing, and I'm just going to highlight it so that it's visible. We know this whole thing, right? It's basically equals to X, right? So here, just to not complicate things and duplicate this 15, what we're going to do, we already know this whole thing, right? Let me just do it on another color because I don't want to confuse you guys. So we know that this whole thing, right, is equals to what? We know the fact that this whole thing is equals to X, right? The one that I highlighted in blue. So we know the fact that this whole thing is equals to X, right? So have that in mind, right? So remember the fact that to find this, what do we need to do? We need to basically minus the intersection, right? So the only thing that I'm going to do here, right, is that I know the fact that this is S is 90, right? So I know the fact that the whole circle is 90, but to find this position is that I need to take out the intersection. So I already know that the blue part is x. So I need to just take out this 20. So it's going to be 90 minus what? Minus 20. Then instead of saying minus 15 and minus 15 minus, what you call this? And saying minus 15, then also saying minus x minus 15, we're going to just say minus x. Because we know that the whole thing is blue, right? The whole intersection that's blue is already represented as x, right? So this is going to give us 70 minus x. So this portion here is basically 70 minus x. It's limiting us from using too many x's, right? So now we're going to move to C, right? So C is going to be the same concept. Remember the fact that we know that this whole blue part is what? It's x, right? And we know the fact that cricket is 63. So we know the fact that we're just going to take out what? We're just going to take out 8, right? So it's going to be what? It's going to be 63 minus 8, which is going to give us what? Minus x, remember? So it's going to be 55 minus x. So this portion here is going to be 55 minus x, right? So now we're going to go back to the information. We see the fact that we have accounted for this, we have accounted for that, we have accounted for that, right? We have accounted for this one, we have also accounted for this one, and we also have accounted for this one, right? And now we're going to account for this 190 boys play rugby, soccer, or what? Or cricket. So what does that mean? It means the fact that in the school, only 190 students play what? Play rugby, soccer, and cricket, right? So what does that mean? Let me just do it visually. So it means the fact that, oh, okay, cool. So it means the fact that if we have, so let me just take my pen, right? So if we have 3 circles, and I'm just going to do it here because I don't want to mess up this one, right? The 190, I want to show you what the 190 represents, right? So the 190 represents this. Do you see the fact that the 190 represents the union? So it represents this, right? So if we're given this, right? If we're given this and we know the fact that the union is equals to 190, right? Is that, and we know the fact that we have a total of 200 students, then the difference between 190, so if you say 200, right, minus 190, meaning we're finding what? We're finding students that are not playing either cricket, soccer, or what? Or what you call this? Soccer or rugby, right? So the 10 is people that are not playing. So if you say 200 minus 190, you're going to get 10. The 10 students, right, are the ones that are not participating in any sports. So here, the 10 is going to go outside, right? So now it's official. Our diagram is actually complete, right? I just wanted to show you outside from this diagram, right? So now we know that our diagram is complete, but we have some parts which are are in form of x, right? So now we need to calculate our x here, right? So let's do that. So before we answer the question, we need to calculate our x's. So it's going to be what? It's going to be, remember the fact that we're adding everything that's in the square, then we're going to equate it to the number of learners. So it's going to be what? It's actually 64, right? Plus 20, right? Then you're going to say plus 70 minus x, right? Then, so this is going this direction. Now we're going to do the intersection that's inside. So it's going to be plus 8 plus 15, right? Then you're going to say plus x minus 15, right? Then you're going to say what? We're going to say plus 55 minus x, then plus this 10, right? It's going to be equals to the total, which is going to be 200. Okay? So now with that said, let's basically what? Let's basically solve for x, right? So we're going to start solving for x. So what I'm going to do is I'm going to add the numbers. So we know the fact that we're going to have 64, right? So I'm going to tick it as we go. Plus 20. So it's going to be plus 20 plus 70, right? So it's going to be plus 70, right? Then I'm going to say plus 8. So this is going to be plus 8. Then you're going to say plus 15. So it's going to be plus 15. Then you're going to say minus 15, right? So it's going to be minus 15. So it's going to be minus 15. Then you're going to say what? Plus 55. So it's going to be plus 55. Then you're going to say plus 10, right? So it's going to be plus 10. So what you're going to get there, you're going to get 200 and what? So you're going to get 200. You're going to get 227. That's what I mean. You're going to get 227, right? So when you add up all the numbers together. So now we're done with the numbers. Let's go to the variables, right? We have minus x, right? So it's going to be minus x plus x. Those two are going to cancel each other. Then we're going to be left with minus x. So it's going to be minus x, right? And this is going to be equals to 200, right? Take the 27 to the other side. You're going to have negative x is equals to 200 minus 27, 200 minus 227, right? Which is going to be negative 27, right? Since they both negative, so x is going to be equals to 27. So we know that x is equals to 27, right? So now we're going to just substitute the real numbers, right? The ones that we're going to work with. So I'm just going to say in red, right? We know the fact that the first one, this one, right? It's 55 minus what? Minus x, which is minus 27. So we're going to have 28 there, right? So here we're going to replace it with 28, right? And then here, remember the fact that what? It's 27 minus 15. So it's 27 minus 15, which is you're going to get as 12. So this portion here is going to be actually 12, right? And then here, right? So here it's going to be 17 minus 27, right? Which is going to give us 43. So this portion here is going to be equals to 43. So that's where our x was, right? So now we are done with filling up the diagram. So now let's go to answering the question. So the first one says, how many boys do not play any of the sports? It's obvious it's going to be the ones that are outside the event. So it's going to be 10 boys, right? So for number one, we know the fact that 10 boys, right? So we know the fact that the total is going to be 10 boys, right? That do not play. So we're going to just say 10 boys, right? Then number 2A, it says what? It says draw a Venn diagram, which is we already did because we needed it, right? Draw a Venn diagram and illustrate the information in the question. But then it says A, how many boys play soccer, right? And rugby, or soccer and cricket. So we see the fact that how many boys that play soccer and is the intersection and cricket, but not rugby, right? So we're looking for the fact that when the boys that are playing soccer and rugby but not cricket, let's go and show it in the illustrated. Let's go and highlight it, right? So let me just pick a color. Let's pick purple. I want a pen. So I'm going to pick purple, right? So where is the intersection between where? Between students, or boys that are playing soccer and rugby. Oh, that's too dark. I'm sorry. Let me just do this. Yes. So our boys that are playing soccer and rugby, let me just take this light blue. Okay, it's already used. So let's take yellow again. It really doesn't matter, right? Because I want to show you where the soccer and cricket is, right? So the soccer and cricket is here. It's the one with the X, remember? Yes, the one with the X. So it's going to be this one, right? This one represents what? This represents soccer and rugby, right? But they say the fact that but do not play what? Rugby. Man, it represents soccer and cricket, right? This is the yellow part that I just highlighted. But they want the ones that they do not play rugby, right? So it's basically finding this portion here. It's this portion minus the main intersection, because the main intersection contains what? Contains rugby in it. So it's going to be actually 12, right? So it's going to be what? We know the fact that this whole section that I just highlighted is 27, right? Because it's X, right? So you already know that. Let me just change my pen. You already know the fact that soccer and rugby, right? Soccer and cricket, sorry, is equals to 27 because that's X, right? But this one contains rugby because of it has the intersection. So we need to take out the intersection. So it's going to be what? It's going to be actually 27 minus 15 because we want the ones that do not play rugby, right? So that's going to be equals to what? So that's going to be equals to what? That's going to be equals to 12. So 12 boys, right, play only soccer and cricket. I hope that makes sense, right? Because if we include this 15, meaning we say the fact that even the rugby players are included there, right? So that's how you would do A. So now let's move on to B, right? So B, it says what? It says, what is the probability, very important, what is the probability that a randomly chosen grade 12 student, right, will take part at least, very important here, they say at least 2 of the sports, right, which is rugby, soccer, and cricket. Then give your answer in decimal form. What is probability? We take whatever we want divided by the total sample. Remember that, right? So now they said at least 2, right? And I think I didn't write it in the extra note. At least 2, we are dealing with what is an addition of the intersection. So let me just write it here. If you get into the question and they say to you at least 2, what does it mean? It means the fact that you're adding up the intersection. So in our case, it's going to be what? It's going to be the addition of what? Of the intersection between what? Between R and S. So it's going to be R and S plus what? It's going to be R, right? So it's going to be R and C. So that represents at least 2 on it. Plus what? Then it's going to be R and what is going to be what? Sorry, it's going to be S and. So it's going to be plus the intersection of what? Of S and C. So that is at least 2. That's what at least 2 means, right? So just remember the fact that if you get in the question and you're doing 3 Venn diagrams and they say to you at least 2, this is what it means, right? So with that said, we're looking for the probability. So the probability of at least 2 sports, right? At least 2 sports is going to be equals to the following. As I said, the fact that what we want is going to be in the numerator. So it's going to be the number of R and S, right? It's going to be plus the number of what? Of R and C, right? Then it's going to be plus the number of what? Of R, S, and C. Then one more thing I forgot is that plus the what? The intersection between all of them. So it's going to be what? It's going to be the middle one. So it's going to be R, right? So it's going to be R. So it's going to be R or, right? ROS or what? Or C. That's what it means at least 2. So, right? So let's just explain what I mean, right? Is that at least 2 is either you can play rugby and soccer, right? That is why the intersection. Or you can play rugby and cricket. Or, and remember the fact that all means plus, right? So that is why it's that at least 2 is that you can play rugby or soccer. You can play rugby and soccer. That is why there is the intersection if you say it out loud, right? Or, which or means the addition, right? So when you say or, we add. So if we say the fact that at least 2, let me just go back again, is that you can play rugby and soccer and represents the intersection, right? Or you add. So this is and this is or. If we had to say it out loud, right? Or, which is we adding, you can play rugby and cricket, which is and, right, is an intersection. Or we add. Do you see that? Or you can play soccer and cricket, right? Again, intersection. Or we add, right? Or you can play cricket and rugby and soccer, which is all of them, right? So that is why it's done like that. I hope it makes sense why at least 2 means what I just did, right? So let me just rewrite it properly here because we need space. So it's going to be, here is going to be the probability of at least 2 sports. So at least 2 sports, right? So in the numerator is what we want. So it's going to be N of the intersection of R and C, right? Plus it's going to be the intersection of R and S. Then it's going to be plus the intersection of S and C plus the whole intersection of all 3 of them, right? So it's going to be, so here, the numbers that we put here, right? Very crucial. The numbers that we're going to put here, right? Oh, not the eraser. So number that we put here, right, are going to be what? The ones that don't have the 15 inside. because of already we're going to have 2 at the 15. And the reason why is that if we add the 15, so now we're talking about more than just two of them, but we're talking about all 3 of them. I hope that makes sense. As I explained here when we talked about when we're just looking at soccer and cricket alone without the rugby, right? So here we're looking at it, it's just rugby and cricket. Now we're going to look at just rugby and soccer, then soccer and cricket alone without the third one being there, right? And which the third one being there is going to be the whole intersection, right? So this is going to be divided by the total sample. So it's going to be NS, right? So this is going to be equals to what? This is going to be equals to rugby, the intersection between rugby and soccer, which is going to be, this one is going to be 8 here, right? Then rugby and what? So rugby and cricket is 8. Then rugby and soccer is going to be 20, right? Then rugby, soccer and cricket is going to give us 12, right? Then the whole intersection is going to be 15, right? So that's what we're going to have. It's going to be 8, right? It's going to be 15, it's going to be 20, and it's going to be 12, right? So that whole thing divided by what? The total number of students or boys, which is going to be 200, right? So now let's add the numerator properly. So it's going to be what? It's going to be 8 plus 20 plus 12 plus 15, which is going to give us 55. So it's the same as 55 divided by 200. But remember the fact that we need to write it in 3 decimal places. So it's going to be 55 divided by 200, which is going to give us what? This is going to be, our probability is going to be 0.275. And that's how you would answer this question. So now we're going to do tree diagrams, right? Tree diagram, the way you need to think about it is that it's an event that affects the results of the next event, right? So the idea of a tree diagram, it deals with like independent, right? Independent. So one event, what happens to it is gonna like affect the next event. And you will see when we're doing calculations, we actually use the independence, formula where the probability of the intersection is equals to, right? You don't like see the fact that you're using it, but you're actually using it, right? But before we do this question, I wanna just show you in more like simpler version on what I mean, right? So let's say we have a bag, right? So if we have a bag, right? So let's say we have a bag, if we have a bag of sweets, right? And inside my bag of sweets, I have 10 sweets, right? So what happens is that in my bag of sweets, I have 10 sweets, right? And in the 10 sweets, I have two types of sweets. I have red sweets, right? So here I'm going to have red sweets, right? And I'm going to have what? I'm going to have white sweets, right? And I tell you the fact that in my white sweets and red sweets, I have a total of how many sweets? Like maybe I have a total of 4 red sweets, right? Then I have a total of 6 red sweets, right? So what is probability? Probability is a chance of getting something, right? So here, my probability of getting red sweets, right? It's going to be what? How many times can I take out red sweets? Is 4 times, right? So my probability or my chance of me getting red sweets, I keep on saying blue, red sweets is going to be 4 divided by the total, which is going to be 10, right? The total is 10 sweets, right? Remember the fact that it's 10 sweets here, right? Then what is my probability of getting white sweets, right? Is what? It's going to be 6 divided by what? By 10. Because I have 6 chances of what? Of getting what? Of getting white sweets, right? Now, I tell you the fact that I want to take the white sweets again, right? So meaning I take, I want to take more than 1 sweet. Here, the first part is just taking 1 sweet, right? I have 4 chances of taking just just red sweets, and I have 6 chances of just taking white sweets, right? Then I'll be like, I'm craving another one. Maybe I want to take 2, right? So what happens is that I'm going to go back into the bag and take again, right? If I go back to the bag and take again, remember the fact that again in the bag, so let's say the first time I picked red sweets, right? and I want to go back and pick maybe another, another sweet. I still don't know what is going to be another sweet, right? But what I know is that because I already took out one sweet, right? What is going to be my total? My total now is going to be 9 sweets because I already took maybe one red, right? So here, how many chances, because of I already took red, how many chances I'm going to be left with only 3, or 3 choices of taking only one red sweets because I already took one here. I hope that makes sense, right? Then here, because of I didn't take what? I didn't take, this represents what? So this would represent red sweets, and this is white sweets, right? So now, what are my chances of taking white sweet at my second try? Because if I didn't take none of them, it's going to be 6. So I still have the whole 6, right? 6 divided by 9, because of now I already took one sweet, right? So here, same applies with here. If I take out 1 from the first try, right? White at the first try, I'm going to be, this is red, right? And this is white. Right? So now if I go back and take out another sweet, how many chances do I have here? I have 4 chances of taking out white sweets because of the first time I took out what? I only took out white, right? But because of I already took out white, I'm going to be left with 9, right? Then this side, it's going to be what? It's going to be 5 sweets because I already took out 1 at the initial try, and the total is going to be 9. So this is the basic concept of a tree diagram. It's one event affecting the other one, right? So with that concept being in mind about the red and white sweet, I'm going to do the question on the side, right? It says if it rains on a given day, right, the probability that it would rain on the next day is 1/3, right? So let's just read the question before I do the tree diagram. So it says if it rains on a given day, the probability that it would rain on the next day is 1/3, right? Then it says if it does not rain on a given day, right? Then it says the probability that it would rain on the next day is 1/6. Then they tell us that the probability that it rains tomorrow, right, is 1/5, right? So now it says the fact that what is the probability that it would rain the day after tomorrow, right? Here, to be honest, it's just English. They were just tricking people through English, right? So what they're asking here is that basically they are, the day after tomorrow is the given day. So the day after tomorrow, right? Do you see this? It's actually the given day, right? So this is the given day. The given day, right? Or in our case, is the next day. Next day. Right? So the given day or the next day is the day after tomorrow, right? Because we don't know what's the given day, right? So now representing this in a form of a tree diagram is that we need to tomorrow, right, is going to be the first branch. So tomorrow is going to be here. So tomorrow, right, is going to be here. So, misspelling tomorrow wrong. Let me just erase that. So it's going to be, let me just take my blue pen. It's going to be tomorrow is going to be here, right? So it's going to be tomorrow, right? So tomorrow, right, is that we have to see the fact that they tell us the fact that tomorrow has 2 parts. Here there's 2 events that are taking place, right? We're looking at whether it's raining or it's not going to rain. That's it, right? So tomorrow, it's either it rains or it does not rain. So it's going to be 2 branches, right? So you only have 2 options. So because of we're talking about rain. So tomorrow, it's either it rains. So it's either it rains or it either does not rain. So we know the fact that it rains tomorrow or not rain tomorrow, right? Either it rains or it either doesn't rain, right? But they already gave us the probability if it rains tomorrow. So we know the fact that this branch is going to be a 1/5. Then how do we get this one, right? Do you see the fact that here the total is 5, right? So we're going to have the same total, right? So we're going to have the same total. So we're going to have the same total, which is 5, right? So here to get what is the chance here? Since this is 1, the numerator, so basically to find the probability, to know the fact that this is correct, is that if I add up these two branches like this one, let's go back to this back thing. If I say 4 divided by 10 plus 6 divided by 10, this needs to add up to 1, right? Because of this is going to be 10 divided by 10, which is going to be equals to 1, right? So this is the same rule here. Is that we already given that 1/5, and this is going to be what? Something, when we add up this two probability, is going to give us what? It's going to give us, it needs to give us 1, right? So how do we do that? Is that it's going to be 1/4. Let's just do it like this. So we need not rain, right? Not rain. We know the fact that not rain plus rain is equals to what? It needs to be equals to 1, right? Then, because of the reason why I'm doing it like this, because of sometimes they might give you in terms of decimals, and I don't want to show you in terms of just fraction only, right? So not rain and rain, it needs to add up to to 1, because of the branches together, it needs to add up to 1. Not rain, we don't know, which is I'm going to name it x, plus rain is 1/5, right? And that's going to be equals to 1. Take the 1/5 to the other side, you're going to get the following. It's going to be 1 minus 1/5, right? Which is going to give us 4/5. So we see the fact that not rain, right, is basically equals to 4/5. So this is going to be 4/5, right? So looking at the total, you see the fact that since we have 1 here, you could have said 5 minus 1, which is going to give you 4, right? If you're dealing with fractions. But if you're dealing with decimals, remember the fact that probability always adds up to what? To 1. Your branches need to add up to 1. I hope that makes sense, right? So we have that tomorrow, it's going to rain or it's not going to rain, right? So we are done with that. Let me just erase this part, right? So now, remember the fact that there is a new event that is affected by tomorrow, right? Which is a given day, right? They tell us the fact that on a given day, right, what's going to happen is that it's either, right, so this is tomorrow, right? Tomorrow we know the fact that it's either going to rain or not. Then on the given day, which is the next day, so this branch, right, represents the next day, which is, this is the next day. This is branches for the next day. Let's say it rains tomorrow, right? Then on the next day, it either can rain or not rain. Do you see that? So it either can rain tomorrow or not rain, right? And same applies if tomorrow rains, it means the fact that on the next day, it can also rain or not rain. So this can either rain or not rain, right? So not rain, right? But they already gave us the probability. It says if it rains, right, on a given day, which is like tomorrow, right? The probability that it would see, if it rains on a given day, this given day is tomorrow, right? The probability that it would rain on the next day is 1/3. So it says the fact that if it rains tomorrow, which is confusing saying this tomorrow and the given day, right? So if it rains like today, which is tomorrow, right? Then the probability that it would rain on a given day is 1/3. So this one is going to be 1/3, right? Then let's just fill up the information before I fill up the missing. Then it says if it does not rain on a given day, which is like tomorrow, the part given day, remember, represents what? Tomorrow, right? And then the probability that it would rain on the next day is 1/6. So the probability that it would rain, it's 1/6. So here it says if it rains on a given day is tomorrow, the probability that it would rain on the next day is 1/3. Do you see the fact that this is the information that I wrote, right? Then here it says if it does not rain on a given day, which is tomorrow is the given day. So this is also given day, right? Then the probability that it would rain, if it didn't rain day before, the probability that it's going to rain in the next day is 1/6. So I filled in everything, right? So now I want to find this one and this one. Remember it's what? It's going to be rain plus not rain is equals to what? Is equals to 1. So it's going to be 1/3 plus not rain, which is what we're looking for. It's going to be equals to 1. So if you say 1 minus 1/3, right, It's going to give us what? It's going to give us 2/3. So it's going to be not rain. It's going to be equals to 2/3, right? So this one is going to be 2/3, right? So apply here. So it's going to be rain plus not rain is equals to what? Is equals to 1. So it's going to be what? We know that rain is 1/6 plus not rain, right? It's equals to what? It's equals to 1. So it's going to be the same as 1 minus 1/6, right? Which is going to give us 5/. So not rain is basically equals to what? To 5/6. So it's going to be 5/6. So this is going to be 5/6, right? So that is your tree diagram filled up, right? So let's just erase this, right? So now it says what? Find the probability that it would rain on a given day. So it says, what is the probability? Let's go back and read the question. It says, what is the probability that it will rain the next day after tomorrow? So we're looking for when it rains in the second branch, right? So it's going to rain here, GC, and it's going to rain here. We are highlighted, right? So that's where it's going to rain. So to find the probability, it's linking it. Do you see? It's linking it to it. Do you see the fact that the branch? I'm just going back and linking it so I can know how to calculate. Where I highlighted, what I'm going to do is I'm going to multiply this, right? And I'm going to multiply this and add, then multiply this. So there's going to probability of if it rains on the given day. So the probability, so let's write this. So to answer this question is going to be what? It's going to be the probability, right? That rain, right? Rain the next day. Rain the day. So it's rain. So the probability that it will, that you can just write the sentence. So I'm going to just say the probability, right? That rain the day after tomorrow, which is the next day. The day after tomorrow, right, is the one that I highlighted. So the day after tomorrow is going to be equals to what? I said the fact that it's going to be this branch here. So it's going to be 1/5 multiplied by 1/3, right? Then you're going to say plus the second branch where it does not rain the following day, but it rains the next day. So it's going to be 4/5 multiplied by 1/6, right? So punch that into the calculator. You're going to get the fact that it's going to be what? It's going to be 0.24. So it's the same thing if they ask, what is the probability? Let me just write here. So if now we're looking for the probability that it will not rain. So the probability, and I'm just going to do it in green, that not rain, right? The next day, the day after tomorrow, which is the next day, right? The day after tomorrow, right? So that's going to be equals to what? I'm just going to highlight the branches here. So it's going to be equals to, I'm just going to do it in green. Not raining, it's here and also here, right? So it's going to be this branch multiplied by what? By this one. Do you see that? So it's going to be this branch, right, multiplied by this one. So this one is always multiplied. So the number that changes is this one. Do you see that? Right? So here, not raining the next day is basically going to be 1 divided by 5 multiplied by what? By 2 divided by 3 plus what? Plus 4 divided by 5 multiplied by what? By 5 multiplied by 6. Punch that into the calculator. So let's do that. So it's going to be 1 divided by 5, right? Multiplied by what? By 2 divided by 3, right? Then you're going to say plus, then it's going to be 4 divided by 5. Then you're going to say multiply by what? Multiply by 5 divided by 6, right? So you're going to have that your answer is going to be what? It's going to be 0.8, right? So that is going to be when it's not raining the next day. And very crucial is that your answer needs to be less than 1. Always your answer probability, your answer needs to be less than 1. If you get something greater than 1, you are wrong. You are doing something wrong. So that's how you would do a tree diagram. So now we're going to move to the contingency table, right? This is probably, if you see this question, you should get excited because if it's one of the easiest between the Venn diagram and the tree diagram. This is the easiest one. If you see it, just be happy that you got it right. So now with the contingency table, what is very important here is basically filling up the table and making sure that every part of the table is complete, right? As you see the fact that in the table we have the total, right? You see the fact that we have the totals, right? So what happens is that the first column, when you add them together, you need to get this total. And also we need to get the total and the parts here, right, of the second column and also the column here, right? So how you would do it is that you're going to look at the parts where you have 2 days where you could find the other one. So in the first column of positive, what do we see? We have the following. We have the males and the females, right? So we can find the total of both males and females. So let's do that. This is before answering the question, right? So we're going to go back and basically read the question. So first answer what you call is fill in the table. So you're going to say 50. So here it's basically going to be equals to, let me just write it. It's going to be 50. Okay, so this is going to be, let me just erase this. So you're going to have the following, right? So it's going to be, why is this acting up? Okay, cool. So it's going to be 50, right? So it's going to be 50 plus 30, right? Which is going to give you a total of 80. So this part is going to be 80, right? So let's go to this one. This one is going to be 120, right? Plus what? Plus 90, because that's the total. So that's going to give us what? 120 plus 90 is going to give you 210. So we're going to have 210 here, right? So that's sorted. So what do we know? We know the fact that this is going to be what? This is going to be the total for positive, and this is the totals of totals, which is the actual total, which is 210, right? So now we need to fill in here, right? So we see the fact that we have 2 missings here. So since this one is the total, it's the same as subtracting this one to get this one, the negative, right? Because 120 is the total. So you can say 120 minus what? Minus 50. So you can say 120 minus 50. It's going to give you what? The females who are negative, which is going to be 70, right? So here it's going to be what? It's going to be 90 minus 30, right? So it's going to be 90 minus 30, right? Which is going to give you 60, right? So now you can add the 70 plus the 60, which is going to give you 130. So you're going to say here 70, right? Plus 60, which is going to give you 130. Or with this one, you could have done it like this. You could say 210 minus 80. You will see the fact that you're going to get 130, right? So if you say 210 minus 80, you're going to still get 130 if you did it this way, right? It really doesn't matter. So this is your entire table filled in, right? So let's just go back and read the question, right? So now what we're going to do is actually we're going to read the information that they gave us, which is everything that's in the diagram, right? But let's understand what is the question about. It says a medical trial is in an effectiveness of a new medication was carried out, right? They tell us the fact that they have a total of 120 females. That's a total, right? 90 males, which is total of 90 males, as you can see through the columns, right? Who took part in the trial. Out of the 50, or what you call this, out of the people, 50 females, which is we have in the diagram, and 30 males responded positively. As you can see the fact that 50 females were positive. Do you see positive 50? Then 30 males were positive, which is 30, right? What you call this, responded positively to the medication. Then they say the fact that below is the contingency table and the given information. Then say the fact that given information is filled in. So the information that they told us is already filled in, right? So question 1 says what? It says, what is the probability that the medicine, right, gives a positive result to females? So what do we see? We see the fact that it's the medication that gives the positive result. Remember what probability we need the total. So this one always in the contingency table is going to be your ultimate total, right? The one by this corner, this is going to be the ultimate total, right? So this is the number that you're going to be dividing with, right? So now with that said, is that what do they want? They want when medication responds positive to female, right? What is the probability of that? We want positive and we want female. Where does it intersect? It intersects here. Do you see that? Because if you go like this and if you go like this, do you see the fact that positive and female, it intersects here. So the probability, so for number one, right? So for number one is that the probability of a positive female is basically equals to 50, right? Divided by the total, which is 210, right? So that's going to give us what? It's going to be 50. I'm just going to leave it in fraction form. Just want to simplify it, 210. So my answer is going to be basically equals to 5 divided by 21. So that's when a female responds positive to the medication, right? So the next question, which is number 2, it says what? It says, and I'm just going to do it with another color, highlighter, different highlighter. So let's try blue, right? It says, what is the probability when the when medication gives a negative result to a male? So we know the fact that this is negative and this is male, where they intersect. So I'm going to take my pen, and we know the fact that this is where they intersect. This is where they intersect. This is here, and this is here. So 60, right? So the probability of what? Of negative what? Negative male is equals to what? Is equals to 60 divided by 210, which is the same as 6 divided by 21, right? So now we're going to do number 3, right? It says what? It says, let me just take my pen, right? It says, was the medication success? What does medication success? Meaning you got a positive result, right? So was the medication success? Meaning positive result are independent to gender, right? So gender, you could either look at male or you could look at female, right? So it depends. You can look at male or you can look at female, right? So with this one, what I'm going to do is remember the fact that we're looking the fact that the independence between what you call this having success with gender, right? So what we're looking for? We're looking for the probability. So independent here, we know the fact that it's basically the probability that we get a positive result, right? A positive result, and the person is female. That's what we're going to be looking at, right? So the person is female. You can also look at it as positive results and the thing is male, right? So I'm just going to look and I'm just going to do the male. I actually do both cases, right? So positive results and we're looking at female, right? Meaning if it is independent, then this needs to be correct. Is that the probability of positive, right, multiplied by the probability of what? Of it being female. That's it being female, right? So this needs to be, we checking whether this is actually correct. So this is going to be your left hand side and this is going to be the right hand side, right? So now the probability that it's positive, right, and female, we actually have calculated it. It's actually this one, right? Because that's the intersection between female and positive. So that is going to be equals to 5 divided by 21, right? Now we need to look for the probability if it's just positive, right? So this is what? This is actually the left-hand side. So for the right-hand side, it's going to be what? It's going to be, we need the probability of what? If it's positive, just positive. Positive is going to be what? It's going to be this total here, right? It's the total of positive from the column of positive. So it's going to be 80 divided by 210, which is going to give us what? Which is going to give us 8 divided by 21, right? Then we need the probability of just females, right? So females is going to be this column here. So it's going to be equals to what? It's going to be equals to 120 divided by 210, which is going to be the same as 12 divided by 210, right? So remember the fact that the right-hand side, right, is basically equals to the probability of positive, right? Positive multiplied by the probability of what? Of it being female. Multiply the two. So when we multiply the two, it's going to be what? It's basically going to be 8 divided by 21 multiplied by 12 divided by 21, which is going to give us the following. So it's going to be what? It's going to be 8 divided by 21 multiplied by what? By 12 divided by 21, which you're going to get your answer as being what? As being this. And I'm just going to write it in decimal. So it's going to be 0.22, right? So let's write this one in decimal. So 5 divided by 21. When you write it in decimal, it's going to be what? It's going to be 0.2324, 24, right? So this one, remember the fact that it was what? It was actually, let me just find it. It's going to be equals to, just want to check whether it's the correct one. Don't want to make a mistake. Multiply by 12 divided by 21, which is going to be what? Yes. So it's going to be 0.22. Do you see the fact that the left-hand side is not equals to the right-hand side? So do you see the fact that this one and this one are not equals to each other? So the events are not independent. So they say, was the medication a success, or the medication success independent to gender? Then explain. You're going to say no, right? The medication, right? The medication success is not independent to gender, is not independent, right, to gender. And the reason is because of, you're going to say what? You're going to say the reason is because of the probability of positive, right, and female, which is the same as positive female, is not equals to what? It's not equals to the probability of positive, right, multiplied by the probability of female. So that's how you would do it. So now I want to squeeze in the calculation if we just looked at male, right? So if we looked at male, we're looking for the probability of it being positive, but now we're just looking at male. I said you could do that, right? And male. It's basically going to be equals to the probability of positive, right? Multiplied by what? By the probability of just it being male, right? So what do we see? We see the fact that this one is already given as what? It's given as 6 divided by 21. And the positive one is also given as what? As 8 divided by 21. So probability of male is basically equals to the total male, which is 90. So it's going to be 90 divided by 210, which is the same as 9 divided by 21, right? So now remember the fact that this is what? This is the left-hand side and this is the right-hand side, right? So now we know the fact that the right-hand side is equals to the probability of positive, right, multiplied by the probability of it being male. Right, so let's multiply them together. We're going to get the fact that this is going to be what? This is going to be 8 divided by 21, right? Multiplied by what? Multiplied by 9 divided by 21, right? So that's going to give us what? It's going to be 8 divided by 21 multiplied by 9 divided by 21. You're going to get your answer as being what? As being 0.16. Do you see the fact that this and this, so I'm just going to highlight that, right? Do you see the fact that this one and this one is not the same thing? So again, it was going to be the fact that they are not what? They are not independent. So either way, even if you looked at it through the female or the male version, you're going to still get the same answer, being the fact that your events are not independent. I hope that made sense. So now we're going to do grade 12, right? So grade 12 is the fundamental of counting principle. So the first thing that we're going to do is going to be what? The fundamental of counting principle. Here, as I said, as you see the fact that I said keyword is choices, right? So we're going to be talking about choices and how to find questions that are dealing with this, right? So this is the formula. Everything's going to make sense when we do the example, right? So the first example, it says what? Let's read the example. And this one, do you see the fact that I said even in the heading, choices without, very important, without repetition. So this is when we're not repeating anything. So let's just read the question. It says, a takeaway has 4 pieces, lunch special, which consists of sandwich, rice, soup, dessert, and a drink, right? For 25 Rand. Then it says it offers the following choices. Keyword, choices, right? Then it tells us the fact that sandwich, we have what? We have chicken mayo, we have tomato and cheese and tomato, right? And we have tuna mayo, right? And we have ham and lettuce. So this is what? This is for sandwich. Let's count how many choices are there. We have 1, which is chicken mayo. Cheese and tomato is the second option. Tuna mayo is the third option. Then ham and lettuce is the fourth option, right? Then under soup, we have either tomato soup, chicken noodle soup, or vegetable soup. Do you see the fact that we have 1? Chicken noodle is number 2 and vegetable is number 3, right? Then we have what? We have dessert. Dessert, we either have ice cream, which is 1, or a piece of cake, which is 2. So we have 2 choices. Then drink, it's either we can have tea, which is 1. We can have coffee, which is a second option. Then we have Coke, right? Which is what? Which is the third option. We have Fanta, which is the fourth option, or we could have Sprite, which is the fifth option. Do you see the fact that we have 5 choices? So they say how many possible meals are there, right? So from here, from the formula here, it's basically taking the total, right, choices and multiplying them together. So for sandwich, we have how many choices? We have 4, so it's going to be 4, right? Then multiply by soup, we have 3, so it's going to be multiplied by 3. Then with dessert, we have 2 options, so it's going to be 2. Then multiply by drinks, which is we're going to have 5, right? Multiply them together, so it's going to be what? It's going to be 4, multiplied by 3, multiplied by 2, multiplied by 5. So that's good. Therefore, we're going to have 120 choices, right? Exactly using this formula, right? I hope that made sense. So now we're going to do the second question, right? And here is without. Very important. This is when we're dealing with repetition, right? So this is like repetition when it's there, right? So let's read the question. It says, a school plays a series of 6 soccer matches, right? For each match, there are 3 possibilities, right? It's either they can be a win, right? They could be a draw, or it could be a loss, right? How many possible results are there, right? So with this one, we see the fact that we have 6 matches. So we know the fact that we have 6 matches, right? And within each 6 match, we have how many outcomes? We have 3 outcomes. So we have 3 outcomes, right? Outcomes. So what could happen is that we could have the first match. So we could have match 1. So let me say match 1. Let me call it match 1. Remember, it's 6 matches, right? Just want to show you guys visually how we got to the calculation. So it's going to be match 1, right? Match 2, match 3, then this is match 4, right? Then match 5, then match 6, right? We see the fact that in each match we have 3 outcomes, so it's going to be 3. It's going to be 3. Each match is going to always have 3 outcomes. Do you see that? So remember the fact that from the formula is that we multiply the outcomes together. Do you see that? Outcomes together, right? So this is the same as what? As 3 to the power what? 1, 2, 3, 4, 5, 6. So this is the same as 3 to the power 6, right? So your answer is actually 3 to the power 6. So your answer here is going to be 3 to the power 6, which is going to be the same as what? Which is going to be the same as 3 to the power 6 is going to give you what? It's going to give you 729. So how many possible results? It's 729. So remember the fact that if you have repeated, right? If your outcomes are repeated like the way it is that your base, right, in your exponential, so it's going to be your base, it's going to be always equals to the outcome, right? Which is, in our case, our base was 3 because the outcome is 3 outcomes, right? To the power of how many matches? So in our case, to the power of how many that thing is repeating, which is in our case is how many matches. Just remember the fact that always the base, right? Because in the question, what would confuse you is that you would maybe sometimes make 6 the base. The base is always the outcome to the power of whatever it is that they're asking you that is repeating, right? So base is always outcome. I hope that makes sense. So now we're going to move to factorial notation, right? Here again, keyword I gave you is arrangement. So here we're dealing with arrangements, right? So the gray formula that I just put there, just ignore it for now. We're going to come back to it, right? So we're going to do the first example. This is what? It's arrangement without what? Without repetition, right? So this is when we are, when we're doing everything without repetition, right? So now let's read the question. It says 8 athletes take place in a 400-meter race, right? In how many different ways, right? How many different ways can 8 places, right? Can all 8 places in the race be arranged? Do you see that? Keyword, right? So here, what I'm going to do it, I'm going to do it in a visual way so that you guys can get how we go to the answer, right? So we have a total of 8 athletes, right? So we have 8 people taking place. So it's going to be this person here, right? There are 8 of them, right? So it's going to be 8 of them, right? So now this is going to take time. So this is 4 so far. So, and remember this is without repetition. 1, 2, 3, 4, 5, right? 6, 7, and 8, right? So it's 8, right? So we have how many positions? We're going to have 8 positions. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? 8 positions. So let's make sure it's 8 before I start answering. So this is 1, 2, 3, 4, 5, 6, 7, 8, right? So it's 8 positions. So if here, how many people can sit in the first place, right? Can take this first position. Do you agree the fact that it can be either one of them, right? It can be either one of them here. They can take this first position, right? It can be this one. 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 It can be all of them, right? So the first position, how many people can sit there? It's all of them. We don't know which one. So it's going to be 8 people, right? So here is that we're going to have 8 at least taking this first position, right? Because if this is without repetition, meaning there's going to be someone that sits here. So let's say for random, this one sits there, right? Then here in the second part, how many people can sit there? Since there is already one person sitting there, how many people are left? Is 1, 2, 3, 4, 5, 6, 7. So only 7 people are left. Let's say maybe the 7th person is this one, right? So we're going to continue, right? So now we left with how many? 6 people that can sit here because of it's 1, 2, 3, 4, 5, 6. 6 people. So let's say randomly this one sits, right? It can be either one of them, but I'm just picking randomly, right? So now in this place, do you see the fact that it's going to be 5, it's going to be 4, because of in each position someone sits, right? And this is going to be 3, this is going to be 3, right? And this is going to be 2, and this is going to be 1, right? So what do we see? We see the fact that the ways of how many, in how many different ways can 8 places be arranged is basically going to be what? 8 factorial. What is 8 factorial if we write it down? It's basically 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. This is exactly the same as 8 factorial. So this is going to be what? 8 factorial. So your answer here is going to be basically 8 factorial. So 8 factorial in your calculator, you're going to say 8, right? Then you're going to say factorial. So this is going to be your answer. It's going to be 40,320. So this is how many arrangement that can be taken place if you have 8 places, right? So now let's do example 2, right? It says same question, 8 athletes take part in 14-meter race. In how many different ways can the first 3 places be arranged? So now we're not going to have 8 places, but we're going to have only how many places? 3 places, because they said the first 3 places. Do you see that? Here it was 8, here it's 3, right? So we already know the fact that how many people can take place here, can sit here is 8, right? Here, if we cancel 1 sitting here, so we're going to have 7, and meaning this one maybe sits there, then here we're going to have 6. So the answer here is going to be 8 multiplied by 7 multiplied by 6, because it's only 3 places. So when you multiply the 3 together, you're going to be equals to what? It's going to be equals to 300 and what? 336. And that's how you would answer this question. So now let's do example 3. This is arrangements, but now it has some restriction in it, right? So it says in how many ways can 7 boys, so we see the fact that we have 7 boys of different ages, right, be seated in a bench, right? So we have 7 boys, so let's do them. So it's going to be, I'm going to just call them boy 1, boy 2, boy 3, boy 4, and boy 5, and boy 6 till boy 7, right? So just to see it visually, it's boy 1, right, boy 2, boy 3, boy 4, then boy 5, and boy 6, and boy 7, right? So it's 7 boys. So number 1 says what? The youngest and the what? And the, so we see the fact that the youngest boy and the oldest boy, right, sit next to each other. So how can we do that, right? So we're going to say boy 1 is the youngest, right? And boy 7 will just say that's the oldest, right? So this is the youngest one, right? And this is going to be the oldest one. So this is going to be the youngest, right? And this is going to be the oldest. They say the fact that they need to sit next to each other. So we have a bench, right? So we have a bench. So this is the bench. I'm just going to do them. So this 2 needs to sit next to each other. So boy 1 and boy 7 are together, right? Then we have a bench. So if boy 1 and boy 2 are sitting together, then the rest of the boys can sit, right? I'm just going to write them like this. So it's going to be like this. So the rest of the boys are sitting, right? Like this, right? So it's going to be like this. Boy 6, right? So if they sitting like this, what is the arrangement? We see the fact that in total we have how many positions? We have 6 positions, right? Do you see the fact that this 2, if 2 things are sitting next to each other, we're going to consider this 2 as being 1, right? So this is going to be the first position. This is going to be the second position. This is going to be the third position, right? And this is going to be what? This is going to be the 4th position. And this is going to be the 5th position. And this is going to be the 6th position, right? So we see the fact that there's how many positions? There is 1, 2, 3, 4, 5, 6, right? I said boy 1 and boy 2, since they're sitting together, they are considered as 1, right? So in total, we have 1, 2. So this is like 1 person now, ne? We have 1, 2, 3, 4, 5, 6. So we're going to say we have like 6 people, right? So in the first position, if they're sitting together, is that we can have 6 options, people sitting here, right? In the first position, right? Then in the second position, it can be what? It can be 5. Then it's going to be what? It's going to be 6, 5. Then it's going to be 4. it's going to be 3, it's going to be 2, it's going to be 1. So this is the same as finding 6 factorial, right? But we know the fact that boy 1 and boy 2, the oldest one, either this one can sit here or it can sit in the second position, right? If I'm just taking this 2, right? Is that I know the fact that here it's either it can be one person sitting, 2 people sitting there, or here one person sitting there. So this is multiplied by 2 factorial for the position of the big brother or the oldest boy and the youngest boy. So this will be your answer. It's going to be 6 factorial because of its 6 positions, right? Taking boy 1 and boy 2 as being 1, but with boy 1 and boy 2, either the older brother can sit in the first position or the younger one can sit in the first position or vice versa. And that is why we account the second factorial, right? The 2 factorial. So this is going to be equals to what? This is going to be equals to 6 factorial, right? Multiplied by what? Multiplied by 2 factorial, right? And this is going to give us 1,440, right? So just to make this here a little bit clear, right, is that imagine if they said the same question, they said the fact that, and I'm just going to do it in a different color. If they said different color, so if they said the fact that maybe the youngest, right, if they said the youngest, the middle, right, the middle one, and the oldest sit next to each other. So they need to be next to each other. Next to each other. I just want to show you what would this happen, right? That means the fact that let's say the middle one is going to be, let's take boy 4 as being the middle one, right? So boy 4 here will be the middle, right? So if that's the case, is that we know the fact that we need to group boy 1, boy 4, and boy 7, right? Because they're going to now be considered as 1. So we know the fact that boy 1, boy 4, and boy 7 are going to be together, right? Then the rest of them, they can come together. So it's going to be boy 2, then boy 3, right? And this is going to be boy 5, and this is going to be boy 6, right? So how many positions are they? We know the fact that this is 1. So it's 1, it's 2, it's 3, it's 4, it's 5. Remember the fact that boy 1, boy 2, boy 3, boy 1, boy 4, boy 7, I take it as one thing, right? So how many do we have? It's 1, it's 2, it's 3, it's 4, it's 5. So now we take it as we have 5 boys, right? So it's going to be 5 seating positions. So it's going to be 1, 2, 3, 4, 5, right? So we're going to have 5 sitting positions, right? In the first one, it can be 5, it can be 4 here sitting, it can be 3, it can be 2, it can be 1, which is the same as 5 factorial. But the position of the youngest, the middle, and the oldest sitting can be in either way, right? So this is going to be what now? It's going to be now looking at like 3 positions, like this, right? 3 positions, right? Because of here, it can be either the youngest one, the oldest one, or the middle one sitting. So this is going to be 3, right? And this is going to be 2, and this is 1. So this is the same as 3 factorial. So for this answer, right, where the oldest, the middle, and the oldest, the middle, and the youngest sitting together, it's going to be what? It's going to be 5 factorial multiplied by 3 factorial, right? Just wanted to show you if they did it in terms of this way, where they wanted the youngest, the middle, and the and the oldest sitting next to each other. Do you see the fact that it's the same thing? But now we're taking account to 3. I hope that makes sense. So this answers number 1, right? And I'll just leave the blue one so that you can see if you had to look at it in another way. So this is answers number 1. So this is number 1. Number 1 answer is this one, right? It's 6 multiplied by, so let me just write it here. Number 1 is 6 factorial multiplied by 2 factorial, right? And that's going to be equals to what? It's going to be equals to 1104, right? Then number 2, it says the youngest and the oldest are not next to each other, right? So you want when the youngest and the oldest are not next to each other. I can rewrite this as what is the complement, right? So This is the same as youngest and oldest not next to each other. It's the same as the complement. You agree is the complement of what? Of next to each other. So this is the same as next to each other. This is the complement. This is the same as saying what? Not next to each other. Do you see that? Not next to, not next to each other, right? So since we can find the complement, it's going to be what? It's going to be not next to each other. So not next to each other, not next to each other is equals to the total. The total, since we have a total of 7 boys, so it's going to be the total arrangement. So it's going to be the total arrangement, right? So it's going to be the total arrangement, and which is I'll calculate, minus what? Minus the next to each other. Next to each other. Each other. Right? So what is the total arrangement? The total arrangement is, since we have 7 boys, meaning it's 7 position, it's going to be the same as 7 factorial, right? Minus not next to each other, which is this one, which is going to be 6 factorial multiplied by 2 factorial, right? So this is going to be equals to what? What you call this? 7 factorial is going to be 7. Then that's going to be factorial. So it's going to be 7 factorial, which is going to be 5,000. So this is going to be 5,040, right? Minus what? Minus 1,440. Then when you pass that into the calculator, you're going to get the following. It's going to be equals to what? It's going to be 5,000, right? And 40. So it's going to be 7. Remember, it's 7 factorial minus what? Minus 1,440. Answer there is going to be what? It's going to be 3,600. So now let's do what you call this arrangement of letters, right? So now finally we can use the gray formula, right? So the first one says, if we take the word omo, right, have how many, what you call this, how many letter arrangement can be there if O is taking as being different? Do you see the keyword different letters, right? So since we have how many letters here? 1, 2, 3. Then for the first one, you just take the total number of letters, then you just put the factorial. So it's going to be 3 letters because it's arrangement, right? So it's going to be 3 factorial. So 3 factorial, when you pass that into the calculator, you're going to get the fact that this is going to be 6, right? Then number 2, that's when you use this formula, right? It says now consider the 2 O's as being identical, right? So we're going to take the 2 O's as being identical. So how many arrangement? It's going to be the total number of arrangement at top. So it's going to be 3, right? So we have 3 letters, right? Divided by the one that are identical. How many are they identical? It's 1, 2, right? It's 2 O's. So it's going to be divided by 2 factorial, right? So this is going to give you what? Punch that into the calculator. You're going to get the fact that this is going to be 3, right? So if you have identical letters, you divide by the identical letters that in the numerator is the total number of letters. So it's exactly this, what you call this formula here, right? Now let's do what you call this. Let's do the number of letters arrangement that are as a longer word, right? If we take the word pursuit, how many different arrangement can you make if 1? So the first one is that when the when the letters are treated as being different, how many letters do we have? We have 1, 2, 3, 4, 5, 6, 7. So for number 1, it's just going to be 7 factorial, right? So when you say 7 factorial, this is going to be equals to what? It's going to be equals to 5,040, right? So number 2, it says, what you call this? Repeated letters are treated as being identical. What you call this? Meaning now they no longer, what you call this? Are different, but they're identical. So here, how many identicals are there? Do we see the fact that S is repeated twice and O is repeated twice, right? It's going to be the total, which is 7 factorial, divided by what? By S, so which is going to be 2 factorial because there's 2 S, multiplied by what? By 2 O's, which is 2 factorial, right? Pass that into the calculator, you're going to get, so you're going to pass that into the calculator, you're going to get the fact that it's going to be what? It's going to be 1,200 260, right? Arrangement, right? So number 3, it says if the word starts with O and the repeated letters are treated identical. So do you see the fact that we have what? We have this. So we know the fact that it's 7 positions. So this is for number 3, right? So we have 7 positions because it's 7 letters. So it's 1, 2, 3, 4, 5, 6, right? And 7, right? So the word starts with O, so it's going to be O here. Then here's going to be the remaining letters, right? So it can be what? Let me just write any word. So it's going to be B, A, S, S, but there's one O missing, so it's going to be like this, right? Because the letter starts with O, right? And remember the fact that they said the fact that we need to treat the rest of them as being identical. So this position, since we start with that one, right, we're going to ignore it. So now, instead of having 7 letters, we're going to have 1, 2, 3, 4, 5, 6. Because we already know what is going to be the first position, which is going to be O, right? So it's going to be 6 factorial, right? Then the repeated letters is 2, so it's going to be 2 factorial, right? And the reason why we do not count for this O, because we already know what is the first position. So only 6 positions are available, right? So this is going to be what? 6 factorial divided by 2, which is going to be equals to 330, right? So now let's go to number 4, right? It says what? It says the word starts and ends. So the word starts and ends with the same letter, right? Letter and repeated, what you call this? They say the word starts and ends with the same letter, right? Letter and repeated letters are treated as being identical, right? So we have 2 cases where we have like 2 identical letters. We have S and O, right? So here we need to add up 2 scenarios, right? So now if we start here, is that if we start with what? With O. So this is going to be 1, 2, 3, 4, 5, 6, 7, right? So the same letter here, it's going to be either S here and S here, right? Then this is going to be the rest of the name. So it's going to be B, A, right? Then it's going to be S is no longer there. So it's going to be O, O. Then it's going to be N, right? So since we know what is the first position and the last position, here it's going to be what? It's going to be 5 factorial. Since we treat them as identical, so it's going to be 5 factorial divided by 2 factorial, right? So it's going to be 5 factorial divided by 2 factorial, right? Plus, right? So plus, because of O, remember the fact that O, it's plus, right? We can have this scenario where the first and the last is S, O, which translates to plus. It can be this one. So it's 1, 2, 3, 4, 5, 6, 7, right? Or we can have that the first and last is O, right? So this is the same as what? This is the same as B, A, then this is going to be S, S, 8, right? So this is going to be O, which is going to be plus, so it's going to be plus. Then this is 1, 2. This is going to be 5 factorial, right? Because this one we don't take account, so it's going to be 1, 2, 3, 4, 5 factorial divided by the identical, which is S, which is going to be 2 factorial, right? So you're going to add them together. So it's going to be what? It's going to be the same as equals to 60, right? Plus another 60, right? Which is going to be equals to 120. So that's how you would do this question. So now we're going to do applications to probability problems, right? So the first one is about a personal identifications number, which is PINs, right? So it says here, right? It says, let's just take a highlighter, right? It says every client at a certain bank has a personal identification number, which is a PIN, which consists of 4 random, right? So 4 randomly chosen digits from 0 till 9, right? So the first question says, how many pins can be, how many pins can be made if the digits can be repeated? The word here is repeated, right? So here, how many choices do we have? How many options or choices do we have? We see the fact that we have choices. We have 0 till 9. So 0 till 9, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Do you see the fact that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? So we have 10 options, right? So we have a total of 10 options, right? Because it goes from 0 till 9. So to answer number 1, so let me just do this. So to answer number 1, it says how many pins can be made if the digits can be repeated, right? So if we can repeat, remember when we were doing the first thing that we did. So remember this, let's just go back so that I don't confuse you guys. Remember when we did this, right? Not arrangement. Remember when we did choices with repetition and without repetition. And I said if we have repetition, it's going to be what? The number of choices to the power of the series, right? So this is the same concept here, right? So this is the same thing right here. So how many choices do we have? We have 10, right? And to the power what? How many pins are there? How many numbers should we choose from? It's 4. So it's going to be 10 to the power 4 for this answer, right? Then number 2, it says how many pins can be made if we are not repeating, right? If now we cannot repeat, this is we can repeat, this is cannot repeat, then we're going to use what? We're going to use the arrangement thing, right? So it's going to be 1, 2, 3, 4. 1, 2, 3, 4, right? So it's going to be 4 positions for 4 pin, right? For 4 numbers for the pin, right? So how many total, right? So here, how many total, options do we have? For here we have 10, here we have 9, here we have 8, and here we have what? We have 7. So our answer here is going to be 10 multiplied by 9, multiplied by 8, and multiplied by 7, right? So it's going to give us what? It's going to give us 5,000. So let's just do it. It's going to be 10 multiplied by 9, multiplied by 8, and multiplied by 7. So it's going to be 5,040. So it's going to be 5,040, right? So this is when we cannot repeat, right? So now let's move on to number 3, right? It says if a pin, right? If a pin is made by selecting 4 digits at 4 digit at random, and the digits can be repeated, keyword can be repeated, right? Then they say to us, what is the probability? So we want the probability that the pin, right, contains at least 1 8, right? So here, the easiest way is that they want the probability of at least 1 8, so at least 1 8, so at least 1 8, right? 1 8 is the same as finding the probability of 1 minus the probability of what? Of this having no 8, right? So it's either we have it or we don't. So at least 1 8, the complement of it is having no 8, right? So now remember the fact that they say the fact that this can be what? Can be repeated, right? We need to find the probability of no 8. So it's the probability of no 8, right? It's going to be equals to what, right? So we see the fact that here, if we say the probability of no 8 is going to be taking out 8, right? This is going to be the same as what? No 8. So before we find the probability, let's find no 8, right? So if we had to find the what? If we had to find the arrangement or how many we can find no 8 if we do not have 8 anymore, right? This is the same as what? As the number of options is going to no longer be 10, but it's going to be 9 options because of there's no 8. So it's going to be 9 to the power 4, right? So this is what? This is when we have no 8 because of we canceled it, right? I hope that made sense. So the probability of no 8, right? So this is going to be what? This is the same as no 8. Let me just fill that in. So it's going to be 9 to the power 4, which is going to be the same as 6,000, right? So it's going to be 6,561. This one, when you find the value, 10 to the power 4, right? It's actually equals to 10,000. So this is actually 10,000, right? So no 8, right, is going to be 6,561. So the probability, right? So let me just do it here. So the probability of no 8 is basically going to be what? The 6,000, right? 561 divided by the total, which is what? Which is going to be 10,000, right? It's going to be 10,000, right? So when we simplify that, we're going to find the fact that it's going to be equals to what? It's going to be equals to 0.66. Going to be 0.66, right? So that I won't confuse you guys, let me erase this part, right? So that's the probability of no 8, right? So with that said, now remember we're finding the probability when what? When at least 1 8, I said the fact that it's 1 minus no 8. So now to finalize this, it's going to be at least 1 8, right? It's going to be equals to 1 minus 0.66, which is going to give us what? It's going to give us 0.34, right? So that is the probability of what? Of what you call this, having at least 1 8, which is going to be the same as 34%, right? So that's how you'll find it, right? So now number 4, it says what? If the pin is made by selecting 4 digits at random, right? And the digits cannot be repeated, meaning we're going to use this method, right? What is the probability that the pin consists of at least 1 8? So it's the same thing, but now what changes is the fact that it cannot be repeated. So it's still the probability of at least 1 8, right? Which is going to be the same as 1 minus the probability of no 8. So now we need to find no 8 in terms of what? In terms of this one, right? So no 8, right, is going to be the same as what? It's going to be the same as, now we're going to have how many positions? Remember, it's 4. The pin is 4, so it's going to be 1, 2. So it's going to be 1, 2, 3, 4, right? So remember the fact that we cancel 8. So how many options do we have? It's going to be 9 multiplied by, so it's going to be 9, right? Erase here. The first position is going to be 9 because of our total numbers is 9. So it's going to be 9. It's going to be 8, right? It's going to be 7. Then it's going to be 6, right? So multiply that. We're going to get the fact that this is going to be the same as what? As this is basically equals to, let me just write it here. It's 9 multiplied by 8 multiplied by 7 multiplied by 6, right? Punch that into the calculator. You're going to get the fact that this is 3,024, right? So this is when we're dealing with what? With repetition, without, what you call this? Without repetition, right? Cannot be repeated. So let me just do this, right? So now we need to find the probability. Remember, it's the probability of no 8. So now the probability of no 8, right? It's going to be equals to this. So it's going to be 3,024 divided by what? Divided by the total. Remember the fact that the total here was what? It's 5,040, right? The probability where we do have 8. So it's going to be the total, which is going to be 5 and 40. So this is going to give us what? This is going to be equals to 0.6, right? So now the probability, finding the equation, the probability of at least 1 8 is equals to 1 minus the probability of no 8, right? Which is going to be equals to 1 minus 0.6, which is our answer now, is going to be equals to 0.4, which is the same as 40%. So that's how you would answer this question. And here, do you see the fact that the key words is what? It's either it can be repeated or not repeated, right? That changes how you answer the question, right? So that's how you would answer this question. So now let's do example 2, which deals with number plates, right? It says a number plate on a car consists of 3 letters. So let's just do this. So we know the fact that it's going to consist of 3 letters. So it's going to be 1, 2, 3 letters, right? And then it says the fact that the letters of the alphabet. So they tell us the fact that of the alphabet, but it's including vowels. So we know the fact that in total we have 5. We have 5 vowels, right? So we know the fact that we have 5 vowels, right? And Q. So we don't have vowels in Q. So it's going to be 5 vowels plus Q. So it's minus 6 letters. So here we know the fact that we have 26 letters. So it's going to be 26 minus 6 is going to be equals to 20. So we have in total 20 letters, right? We have 20 alphabets that we need to work with, right? So the alphabets here is going to be 20 of them, right? So we're done with the first part. So it's followed by 3 digits. So we know the fact that this is alphabet, right? So this is going to be alphabet. And this is going to be digits, right? So we see the fact that our digits is going to be what? It's going to be 3 digits that are going to be there, right? So it's going to be 3 digits, right? And the digits is from 0 till 9. 0 till 9, meaning we have 10 in total digits, right? And they say for a chosen car, right, what is the probability that the number plate starts with Y? So for a chosen car, what is the probability that the number plate starts with Y? So we're starting with Y, right? And they say the fact that, starts with Y and ends with the vowel. So from the 10 digits, let's find how many vowels are there, right? So I'm just going to write it. I know the fact that it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So vowels are this one, it's this one, it's this one, it's this one, and it's this one. So how many vowels do we have? We have 1, 2, 3, 4, 5. So we know the fact that the last position, we're going to have 5 options, right? So we're going to have 5 options there, right? So here we're going to have one option here. Here, this Y is going to be one option, right? Because it needs to start with Y. Then for the digits ending, it's going to be what? 5 options, right? So this is translating what they said here, right? So here we need to know how many options are there. So here for the alphabets, right? It's going to be what? How many options do we have for alphabets? It's going to be 20 options here, right? Then here, remember the fact that we don't mind repetition, right? So again, how many options of alphabets here? It's going to be 20, right? Here, how many options of digits? It's 10. And here it's going to be 10 again, right? So this is what translating this situation. Remember the fact that we're looking for what? For probability. So this is the one in the numerator. This is the one, the number that's going to be in the numerator, right? So now we need the total because the total is going to be in the denominator. The denominator, we know the fact that we have what? We have 3 alphabets, right? And then we have what? We have 3 digits, right? So how many options of alphabets here? Remember the fact that the denominator is the total thing, is the total scenario. So we have the first position, it can be any number. So it's going to be 20 alphabets, 20 here, 20 here, right? And here's going to be 10 because the first position can be 10 alphabets. Choices is 10 numbers. Then here can be 10 again, and here going to be 10, right? So now translating what we just did here into into numbers, right? Since here we need to have Y being there, right? It's only one option. So it's going to be 1 multiplied by 20, multiplied by another 20, then plus this one's going to be plus 10, multiplied by 10. Then here, because of these 5 vowels, you have 5 options. So it's going to be multiplied by 5, right? So punch that into the calculator. You're going to get the fact that it's going to be 200,000. So it's going to be 200,000, right? So now let's translate this one. It's going to be 20 multiplied by 20, multiplied by another 20, multiplied by 10, multiplied by 10, multiplied by 10. So when you punch that into the calculator, you're going to get that as being what? As being 8 million. Right? So we're looking for Y for the probability, right? Of what? Of starting with Y, right? So starting with Y, so start with Y and ends with odd, right? Ends with an odd digit, right? So that's going to be equals to what? That's going to be equals to, start with this scenario where we start with Y and end with odd. It's going to be 200,000 divided by the total, which is going to be 8 million, right? So it's going to be 8 million. Punch that into the calculator, you're going to get your answer as being what? So if you say 200,000, so it's 1, 2, 3, divided by 8 million, 1, 2, 3, 4, 5, 6. So you're going to get your answer as being what? As being 0,024 5, right? Change that into a percentage. This is the same as 2.5%. And you are done answering this question.
So now we're going to move to this question where you're dealing with probability. Just a reminder, or just want to fix this here, you're basically finding the probability, right? So you're finding the probability. I think they didn't state it, they just said how many ways, right? And you basically need to find, not me spelling probability, wrong. So you basically finding probability, right? And since the spelling of probability ran away from my mind, it is okay. Just know the fact that we're finding probability. So just to rephrase this question, which is we're going to look at that one. The first one is sorted. The first one, the why I wrote the answer is because I'm going to need it to basically solve the third one, right? It says how many ways can the letter be arranged in no similar way if no similar letters should be close to each other, right? The easiest way to solve this type of question is that you need to find you need to find the complement. Yes, you need to find the complement of the question, right? So here they said no similar, is that to find the probability of that, I'm just going to write it here. The probability of no similar, right? No similar letters should be close, right? Should be close to each other. That is basically the same as saying 1 minus the probability of similar letters should, right? Should be close to each other. Why do we do it like this? It's very easy to find this one than to find this one. It's very easy to find the the arrangement where the letters are close to each other versus finding the arrangement where they are not close to each other, right? So with that said, we know the following, right? We know the fact that our word is calculator. So we know the fact that our word is calculator, right? So we know that our word is calculator, right? So since our word is calculator, I'm gonna highlight similar words. We know the fact that this, we have 2 C's, and I'm just gonna change the color. We have 2 L's, right? And we have 2 A's. We have 2 A's, right? So we see that, right? So remember the fact that what are we looking for? We're looking for this probability, this one, right? We're looking for the probability for this one. But to find the probability of this one is that first we need to find the arrangement where the similar letters are, are next to each other. That's what we need to find. So we know the fact that our letter, right, our word is 10 positions, right? So we know the fact that our arrangement is 10 position. So it's going to be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, right? So we know the following. We know the fact that since the letters that are similar need to be each next to each other, is that this is the following. This is going to be 2 right here. This is going to occupy the first position, which is going to be C, right? So this is going to be C. Then how many C's are there? Are 2, right? So it's going to be basically 2 factorial. Then now we're going to occupy it by A, which is 2 of them, which is similar letters. Then this one is going to be L, which is going to be 2 of them, right? So we see the fact that these ones are when they are next to each other. Then looking at it, how many letters are left from here, right? How many letters is going to be the following. We see the fact that we have 10 letters of minus 3. We're going to have 7 letters. So how many options do we have here? We have 7 options. Here, obviously decreasing, is that we're going to have 6. Then we're going to have 5. We're going to have 4. We're going to have 3, we're going to have 2, we're going to have 1. This portion here is the same as saying what? 7 factorial, right? And here, since it's an arrangement, and how many options do you have is 2. So this is going to be the same as 2 factorial. Also here is going to be 2 factorial because it's 2 options. And also here is going to be 2 factorial. So your number of arrangement is basically
2 factorial multiplied by 2 factorial multiplied by 2 factorial multiplied by 7 factorial, right? So now remember the fact that you're finding the probability of this, which is similar letters, right? Similar letters should be close to each other, right? Close to each other, right? Remember the fact that when you're finding the probability is whatever condition that they gave us, which is that the top part that we found here, which is going to be 2 factorial multiplied by 2 factorial multiplied by another 2 factorial multiplied by what? By 7 factorial divided by the total. In our case, the total is number 1. The total is what? How many different word arrangement can be made from all the letters of the word calculator. That is our total. That's in general how many arrangements can be made. So our answer was this, which is what? 453, right? And 600. Punch that to the calculator. You see the fact that that probability is going to be what? It's going to be 4 minus 45. But remember what we're looking for? We're looking for no similar letters should be next to each other. So this is going to be the same as the probability of no similar. I'm just going to call it no similar because writing that whole sentence, it's too long, right? It's basically going to be equals to 1 minus the probability of, I'm just going to call it similar. Similar is this one, right? Or this one in our case, right? So it's going to be similar, right? So we know the fact that this is the probability, which is 4 over 5. So this is going to be equals to 1 minus 4 divided by 45. Punch that to the calculator. You're going to find the fact that your answer is 41 divided by 45, right? Which is the same as 0.91, right? Which is basically the same as 91%, right? So that is the probability where no similar letters should be next to each other. I hope that makes sense. And that's how you would answer that question.